Meet Lise Meitner, a brilliant physicist whose profound story balances monumental discovery with historical injustice. As the co-discoverer of nuclear fission, Meitner fundamentally reshaped our understanding of the atomic world. Yet, despite her groundbreaking contributions, she faced one of science's most notorious Nobel snubs, with the Chemistry Prize awarded solely to her longtime collaborator, Otto Hahn. Beyond the laboratory and the shadow of political exclusion, Meitner's legacy is defined by an unwavering dedication to ethics. She steadfastly refused to work on the atomic bomb, cementing her reputation as a visionary scientist who never lost her humanity. This is the case file of Lise Meitner, a towering figure in 20th-century physics whose accolades by peers stood in stark contrast to her recognition by the Nobel Committee. Despite receiving a staggering 48 Nobel Prize nominations, 19 in chemistry and 29 in physics, she was awarded 0. Her milestones tell the story of a trailblazer. In 1906, she became the second woman to earn a physics PhD from the University of Vienna. By 1926, she was Germany's first female full professor of physics, and in 1938, she co-discovered the mechanics of nuclear fission. Her immense impact earned her the highest praise from Albert Einstein himself, who revered her as the German Marie Curie. This blueprint maps Lise Meitner's early career as a relentless journey through institutional glass ceilings across 3 critical nodes. In 1890s Vienna, women were banned from public higher education. Meitner shattered this barrier by cramming 8 years of secondary school into 2 years of private tutoring to pass the Matura exam. Next, at Vienna University between 1901 and 1906, she navigated a heavily male-dominated physics landscape, securing a breakthrough PhD. Under the mentorship of Ludwig Boltzmann. Finally, arriving in Berlin in 1907, she faced strict Prussian bans on female students and a chemistry director who literally feared women's hair catching fire. Undeterred, she worked unpaid in a basement woodworking shop, uniquely championed by Max Planck. This slide illustrates the decades-long scientific synergy between chemist Otto Hahn and physicist Lise Meitner from 1907 to 1938. Hahn's expertise lay in the meticulous isolation of elements and identifying chemical properties of radioactive isotopes. Meitner brought the physics perspective, focusing on understanding radiation, interpreting beta-gamma decay sequences, and explaining the physical why behind their chemical findings. Together, their complementary skills led to a powerful intersection of shared breakthroughs. In 1909, they discovered radioactive recoil, followed by the momentous discovery of protactinium, 231 in 1917. The timeline also highlights Meitner's individual brilliance, noting her independent 1922 discovery of the Auger effect, a fundamental radiationless atomic transition. This dramatic map marks the turning point of 1938. The fracture of exile. Following the March 1938 Anschluss, Lise Meitner was stripped of her protective Austrian citizenship and venomously denounced by a Nazi colleague. Forced to flee, her perilous escape unfolded on July 13, 1938, when physicist Dirk Koster smuggled her by train from Berlin to the Dutch border city of Groningen using an invalid passport. Traveling light and in terror, her inventory consisted only of summer clothes, 10 marks, and a diamond ring inherited from Otto Hahn's mother to bribe guards if caught. Her narrow escape eventually led her to Stockholm, leaving behind a harrowing moment where she recalled her heart almost stopping during 10 minutes of agonizing waiting. This slide details Lise Meitner's exile in Sweden, a period where she was forced to lead groundbreaking scientific discovery from the shadows. In Stockholm, she faced a harsh reality. Reluctantly hosted by Man Siegbahn, she was given bare laboratory space but denied collaborators, equipment, technical support, and even her own set of keys, leading her to call it her exile from physics. Yet a vital lifeline kept her connected to Berlin. Through continuous secret correspondence with Otto Hahn, Meitner remained the crucial theoretical architect of their ongoing experiments. Even from afar, her intellect guided the pioneering work of bombarding uranium with neutrons, proving that her scientific mind could not be sidelined. This slide captures the pivotal moment of the barium anomaly, where a chemical impossibility demanded a revolution in physics. In December 1938, Otto Hahn sent a letter from Berlin detailing a baffling experiment. Bombarding uranium, with an atomic mass of roughly 235, with neutrons unexpectedly yielded barium, which has a much smaller atomic mass of about 141. Confused, Hahn pleaded. It cannot burst into barium. What would physics say about such bursting? In Stockholm, Lise Meitner faced this extraordinary challenge. The prevailing scientific wisdom dictated that nuclei could only shed tiny alpha or beta particles. Splitting a heavy atom completely in half was considered impossible. Meitner was tasked with finding the physical explanation to validate Hahn and Strussmann's chemical proof. This slide depicts the epiphany in the snow, the historic moment Lise Meitner calculated nuclear fission. While walking in the snowy Swedish woods with her nephew, Otto Frisch, Meitner sketched out the revolutionary physics on a scrap of paper using George Gaimov's liquid drop model. She visualized a neutron striking a uranium-235 nucleus, causing the excited nucleus to elongate and vibrate like a drop of liquid until it fractured. The split produced barium-141, krypton-92, and extra neutrons. Crucially, Meitner realized the combined new pieces were lighter than the original atom. Applying E equals mc squared, she deduced that the missing mass, just 1/5 of a proton, was converted into a massive 200 MeV of kinetic energy. Witnessing this atomic cell division, Frisch borrowed the biological term fission to name the phenomenon. This slide confronts the weaponization of science, highlighting Lise Meitner's absolute moral clarity during a time of global conflict. Her powerful declaration, "I will have nothing to do with a bomb," stands as a definitive rejection of the dark applications of her discovery. Despite uncovering the exact physical mechanism that made nuclear weapons possible, Meitner categorically refused prestigious offers to join either the British mission or the Manhattan Project at Los Alamos. Choosing integrity over the geopolitical spotlight, she remained in Sweden, steadfast in her unshakable belief that science should never be used as an instrument for human destruction. This slide presents the credit matrix, a direct breakdown dissecting the uneven distribution of recognition for the discovery of nuclear fission. It compares 4 key figures across their experimental roles, locations, publications, and Nobel outcomes. In Berlin, Otto Hahn managed the experimental setup and chemical identification, while Fritz Strussmann assisted with the chemical analysis. Their January 1939 Naturwissenschaften paper claimed the discovery of barium, but lacked a physical explanation. Meanwhile, in Swedish exile, Lise Meitner provided the crucial theoretical architecture and physical interpretation, E equals mc squared, partnered with Otto Frisch in Denmark, who acted as co-theorist and replicated the experiment. Together, they published the complete physics and mechanics of nuclear fission in Nature in February 1939. Ultimately, the 1944 Nobel Prize in Chemistry named Hahn as the sole recipient, completely excluding Strussmann, Frisch, and Meitner. This slide presents the anatomy of a snub, charting the 4 intersecting forces that erased Lise Meitner from Nobel recognition. First, anti-Semitism and exile forced her out of Germany, leaving her unable to co-author the initial paper as the Nazis wiped her from official physics records. Second, gender discrimination left her isolated in Sweden under Man Siegbahn, a host heavily prejudiced against women in science. Third, disciplinary silos meant the Nobel Chemistry Committee evaluated the prize, fundamentally failing to value the theoretical physics explaining the chemical anomaly. Finally, a post-war narrative took hold as Otto Hahn actively downplayed her role, rationalizing her exclusion to distance German science from Nazi-era collaboration dynamics. This timeline charts Lise Meitner's late recognition, an ultimate historical vindication. While the Nobel Prize famously eluded her, the decades following World War II brought prestigious honors that cemented her colossal impact on science. In 1946, she was named Woman of the Year by the U.S. National Press Club, famously greeted by President Truman. Vindication continued in 1949, when she was awarded the Max Planck Medal jointly with Otto Hahn. In 1966, she made history as the first woman and first non-American to receive the U.S. Enrico Fermi Award. Finally, in 1999, the Royal Swedish Academy of Sciences permanently honored her legacy, striking a commemorative medal inscribed, Fissionum nuclearem illustravit. She explained nuclear fission. This slide presents the ultimate cosmic tribute to Lise Meitner. Etched into the universe. Element 109. First synthesized in 1982 by German researchers, the radioactive element was officially named meitnerium, MT, in 1997. This honor carries historic weight. Meitner stands as the only non-mythological woman to have an element named exclusively in her honor, as curium is shared by Marie and Pierre Curie. Now a permanent fixture on the periodic table, meitnerium represents a legacy written into the very fabric of matter, forever outlasting the discriminatory political regimes and biased committees that once sought to erase her brilliant contributions to human knowledge. This concluding slide distills a legacy of brilliance and integrity, summarizing the profound journey of Lise Meitner. She successfully navigated institutional sexism and fled a fascist regime with practically nothing to her name, only to unlock the greatest energy source in the physical world. Despite suffering one of history's most glaring academic snubs, she never lost her moral compass. The presentation closes with her beautifully fitting epitaph, penned by her nephew Otto Frisch, which perfectly captures the essence of her life and work. Lise Meitner, a physicist who never lost her humanity.